Hello and welcome to 5 Minute Math. Today we are looking at the third grade readiness practice for 3.2D comparing and ordering numbers. This is the Proficient version. If you're interested in looking at the intermediate and advanced versions or readiness practice materials for any other standard, you can do so by using the link in the video description. So our first practice problem asks us to identify a mystery number, and we need to come up with 4 different numbers that meet these criteria. So let's just go ahead and put down here that answers will definitely vary. I'm going to show you some different options and model the thought process, but your answer might be different than mine, and if so, that is fine as long as it meets the criteria that I'm about to lay out for you. So let's look at what we have. We've got number between. All right, so I'm going to first make a number line here. It needs to be between 19,421 and less than 58,901. So I've got a lot of numbers to work with. All right, and then we're talking about digits. So I'm going to build a place value chart here that's going to kind of keep my thinking. Since the maximum number is 58,901, I know that it's not going to be more than the 10,000s place. So I really only need 5 digits here to work with. So I've got my 10,000s, my thousands, hundreds, tens, and ones. All right, so it's between those two numbers. The value of one of the digits is represented by 4 times 1,000. Well, that means that I'm going to have a 4 in my thousands place, because if I wanted to have a 4 times 1,000, that would be 4,000, which means it's 4,000, 4 in the thousands place. So I've got those 2 clues ready to go. The hundreds digit is 10 times greater than the tens digit. All right, so let's see what that would look like. So if my hundreds digit is 10 times greater than the tens digit, right? So if I put a 1 in the hundreds place and a 1 in the tens place, well, that 1 is really a 100, and that 1 in the tens place is really a 10. And 100 is 10 times 10, or 10 times greater than 10, so I could do that. Now, sneaking a look ahead, my number needs to be odd, so that's just going to affect my final digit. So I can go ahead and continue this. If I have a 2 in the hundreds place and a 2 in the tens place, that's the values of 220, and that's going to work. If I have a 3 in the hundreds place and 3 in the tens place, right? 10 times greater than 30 is going to be 300. So whenever you see a clue that says that one digit is going to be 10 times greater than the other digit, that means that they are going to be next to each other, and they're going to be the exact same digit. Because if I made one of them 6 and one of them 5, then you can't say that one digit is 10 times greater than the other. To be exactly 10 times greater, you need to multiply what's in the tens place by 10, and that gets you up to what's in the hundreds place. So I've got all of these options here to choose from. And then finally, it does say I need to be odd. So that means I can choose between 1, I can choose between 3, I can choose between 5, 7, or 9. But I'm going to exclude 0, 2, 4, 6, or 8. All right, so like I said, I've got many, many options here. So it doesn't really matter what my 10,000s place, as long as it is between the 19,000 and the 58,000. But you know what? We can go ahead and narrow that down. Look what happens if I put a 1 right here. If I made this a 1, I know my thousands needs to be 4,000. So that would be 14,000 something. And 14,000 is going to be less than 19,000, so I can't choose it. So that means I can put a 2 here if I want to. 24,000 something could work. 34,000 something could work. 44,000 something could work. And 54,000 something could work. If I put a 6 there, now I'm 64,000 and I'm too large. So I only have 4 digits to choose from in my 10,000s place. So let's now take a look at some answers. I'm going to show you a few answers. Remember, answers will vary, so let me show you 4 different answers. All right, so let's start with a 2. So 24,000, because remember the thousands place needs to be 4. I need to select 2 of the same digit for the tens and the hundreds, so I might say 22. And then I need a digit that's going to make it odd. So I could say 24,229. So let's say I put that right around here. 24,229. Now, if you want to just follow the pattern, you can write 24,000 and then change that to 22 for the 33, 44, 55. That works. I'm going to switch it up just a little bit, but sometimes it's really great just to find something that works and then make one slight change. So I'm going to do 34. Now that 4 has to stay in the thousands place. But instead of 22, I'm going to put 66. All right, that's 660. And let's make it 1. So let's make it like this. So that's going to be 30, just my guess is where that would land, 34,661. Right, so that meets all my criteria. I need 2 more. So let's do, I guess I do have a pattern. I'm going up by ones in my 10,000s. 44,000. Then I need to choose 111. So we can put that right there. That would match right there. So 44,111. And then another option could be 54,000. And let's choose something else. Let's do 773. So once again, I am just choosing a few different options. Your answers might be different than mine, but we need to have these criteria. The the 10,000s digit needs to be 2, 3, 4, or 5. The thousands digit has to be 4. The tens digit and the hundreds digit need to be the same digit, either 1, 1, 2, 2, 3, 3, so on. And then your ones digit has to be odd, so 1, 3, 5, 7, or 9. Our second number here, we have a table with a list of Texas cities, and we need to compare them. We want to put them in order from smallest to largest, and we want to find the city that is fourth. Now, if we look at our standard, the standard does ask us to compare numbers up to 100,000, but we're wanting to push a little bit past that. We're going to use the same thinking to get us, so we're going to go just a little bit above that 100,000. And so we want to visit these cities in order from smallest to largest. Okay, so that's going to be least to greatest, right? And then if we're going to do it in that order, which will he visit fourth? That's our question. So let's first build a place value chart. So all of these go to the 100,000s place. So let's line them up like that. And so we're just going to put 100,000, and we're going to do it 10,000, 1,000, 100, tens, and ones. And first, I just want to put them all down. So let's start with Carrollton. And that's going to be 132,706. And we can go to Pearland. It's going to be 128,316. Let's go to the Woodlands. Next, we are 122,494. Next, we will look at College Station. And we will say that that is 126,665. And then we need one final color here. And so let's do Abilene. That is 130,251. All right, so now that we've got our numbers down, what we need to do is we need to look at, make that just a little bit straighter. Let's get that 4 right here. All right, so we need to look at the largest place value first. So what is our largest place value? Well, our largest place value is the 100,000th place. We're going from smallest to largest, and so we can just put that right here. I'm going to put this little line right here. I'm just going to write these from least, greatest. Now, my smallest is going to have the smallest in the, well, if we look at our 100,000s, the 100,000s are all the same. It's all 1. So we need to move over to the next place value, 10,000s. Now look what I've got. I've got 3, 2, 2, 2, 3. Okay, so for my smallest, I'm going to look at these 2s. That's what's going to help me next. So right now I'm kind of ignoring Carrollton, ignoring Abilene. I'm looking at my 2s, but now my 2s are all the same. So now I need to go to the next place value. So I'm going to live between the Pearland, the Woodlands, and College Station. And if we look at the thousands place, we see that the Woodlands is the smallest. It's got a 2 in the thousands place. So that is our smallest city. So I'm going to write the Woodlands and put a little check mark so we don't look at that one anymore. Now, still living between Pearland, the Woodlands, and College Station. The Woodlands is going to be our smallest. Next is that 6, that College Station, 6 in the thousands. So we can say College Station, which means that leaves us with Pearland. All right, so I have taken these 3. Now what I could do is I can zoom back out and I can look at the other 2, the 2 that have the 3 in the 10,000s. Now they're tied for in the 10,000s and the 100,000s, so we need to look at the thousands, but that is going to get us a 2 and a 0, and 0 is smaller than 2, so we're going to put Abilene in here next, and then we're going to end up with Carrollton. That is our greatest. Now, this one did not say listed in order from least to greatest. What this one asked us to do was this one asked us to say put them in order from least to greatest because that's the order in which Juan Carlos is going to visit the cities. We need to find the one that is listed 4th. So if we go from the left, we will see that we have 1, 2, 3, 4th. Abilene is our answer because that is the city that Juan Carlos would visit 4th. Next, for number 3, we have 2 numbers that we need to compare here. And let's just go ahead and build a place value chart. You see these 2 numbers are within the 10,000, so I'm just going to build my place value chart that goes up to there. 10,000, it's 100, it's 10, that's a 1. So let's just draw these 2. So I've got Oakdale. Oakdale Library is 14,057. And our Willow Creek branch has 14,075. So let's get that there. We are going to compare these 2. So 14,075. We don't say 14,075, 14,057. That and is reserved for the decimal. So we're just going to say 14,057, 14,075. So when we are comparing these, we start from least to greatest, or from greatest to least, excuse me. We're going to start from our largest place value. So we notice that the 10,000s are both 1, the thousands are both 4, the hundreds are both 0, which means we really need to look at this tens place right here. And really we're comparing 57 and 75, because other than that, they both have 1 10,000, 4,000s, and 0 hundreds. And we see that that 57 is going to be less than that 75. So let's write this down here. We would say 14,057. If we wanted to leave a spot for our symbol, we would say less than is less than 14,075. That's how we would answer that problem. If you are interested in the intermediate or advanced versions of this resource or any other readiness practice resource, you can find those using the link in the video description.